GATE 2017 Metallurgical Engineering Question 33. A Powerbeck's plot of the reaction Al3 plus 2H2O equal to AlO2 plus 4 hydrogen ions in potential versus pH diagram is. Okay, we need to identify which diagram corresponds to this reaction. Since there are two ionic species involved, Al3 plus AlO2 minus, okay, and since there is no change in the valence of aluminium present in the two ionic species considered, okay, so the associated equilibrium is independent of the potential, and the expression of that equilibrium, it can be derived in the following expression for the standard condition. That is, here Q that is expressed in this equation is the activity of AlO2 negative into activity of hydrogen ions 4 on activity of aluminium 3 positive into activity square of H2O. Now, assuming the activity of H2O is 1 and the activities of two ionic species are equal, that is, what are the two ionic species? Al3 plus AlO2 negative. Let us assume that their activities are equal. A simpler expression of the equilibrium in the equation is based purely on the activity of H plus ion. Okay, so it will be RT ln H plus 4 equal to minus delta G reaction. Understood? Or you can write log to the base 10 H plus ion is nothing but minus delta G reaction upon 4 into 2.303 into RT. And log to the base 10 hydroxyl ion is nothing but pH. We call it as pH or minus pH. So pH comes out to be 4.38 into 10 raised to power minus 5 into delta G naught reaction. Fine. So this delta G of reaction can be calculated from literature using standard thermodynamic data. Okay, it is constant. Fine. So it means the pH is also constant. If pH is constant, in which graph shows the pH constant? Graph C. Okay, where pH is held constant. Okay, so here it is shown the pH comes out to be for delta G from literature. The value of delta G can be 120.4 kilojoule per mole. For this value, the pH calculated will be around 5.27. Okay, and it will be held constant in this equation. Fine. So option C is the correct answer. What about the rest of the options? Now the vertical line here, okay, it shows that there is no electrons are exchanged. Okay, and the equilibrium depends on the concentration of H plus ions only. Okay, and it is not affected by the electrode potential. While in case of horizontal line, okay, this shows that in this equation H plus or OH negative ions are not involved in the reaction, and the boundary line is horizontal and it is independent of pH. Okay, only exchange of electrons are taking place in this kind of process. Okay, so that is pH independent process. pH independent. While in case of sloped lines, in this case both electrons and H plus ions are involved, and electrode potential is a function of pH. And the equation can be written as, okay, here both electrons and hydrogen ions are involved, so you will get a sloped boundary line. While in case of horizontal boundary line, the equation can be written as, on the other hand, in case of vertical boundary line, the general equation will be like this. So to know more about the Powerbeck's plot, kindly refer lecture number 7, Environmental Degradation of Materials by Dr. Claude Mondal, Department of Materials and Metallurgical Engineering, IIT Kanpur. Thank you.